I'm assuming you want to start right now, right?
Yeah.
Okay. So now it's broadcasting. When it's done, you hit stop broadcast. There'll be a couple of additional steps. If you're not sure, just go grab Jen and we'll wrap it up. But at least it is actually recording now. So. All right.
Thanks. All right, sorry about the late start. Technical difficulties there. So we want to come here today just to speak a little bit about our experiences in turning educational research projects, kind of grant-based projects, into sustainable web apps, particularly using our ThinkSpace framework. I'm James Fitterlich. I'm one of the developers. I've been involved in the project since around 2007.
I'm Jose Camus, and I'm the UX designer for ThinkSpace.
So kind of as our agenda, first answer the big question, what is ThinkSpace? And then we'll kind of talk about the user research that went into it, the design aspects, and kind of our technology stack, what powers it kind of under the curtain. So what is ThinkSpace? Essentially, it was conceptualized around this problem. What is the best way to support multiple independent research projects that ended up having kind of a web component in this case? What's the best way to do that of kind of the economy of scale approach? We wanted to make it affordable for these researchers to come onto our framework and support their grant work, rather than having all of these isolated independent things that Iowa State University, for example, kind of where all this started at, had to have separate people to manage and have the manpower behind that. So kind of the real world scenario of it is in 2007, Dr. Pete Boysen at Iowa State University was approached by two separate faculty members. Each of them had completely different disciplines. They had totally different projects that they wanted to develop into an educational web tool. That is kind of what ended up spawning the concept of ThinkSpace. So ThinkSpace is it's this foundation that supports all of these multiple research projects. Rather than rolling authentication for every single one of them, rather than having kind of the how do you manage your data and all of that stuff, we rolled that into the kind of the one ThinkSpace framework that supports all of these kind of independent pieces. So essentially what that kind of looks like over time is we have all of these different disciplines now that are all supported by this singular framework called ThinkSpace. And just as kind of a picture, what we're working on now is kind of the second iteration of it. And this is the screenshot from the first version of it that was done that started in 2007. This is one of the modules that was supported. It was this is a veterinary science application, kind of a case study in terms of how do you diagnose an animal. And it takes you through kind of the the logical thought process that goes along with that. And just kind of some factoids: we are not in LMS. We never will be. That is not our goal at all. This is a completely separate concept. To date, we've been supported from instructional grants from NSF, USDA, Sloan Foundation, and Department of Education. So as I just kind of mentioned, one of the big things that we're doing is kind of rewriting it from the ground up to utilize more modern technologies. It used to be done in Smart GWT. It was a NoSQL type approach using flat file XML. We're trying to modernize it using Restful Json Apis and things like that. So for now, I'm going to segue over to Jose and he'll start talking about some of the design aspects. So it doesn't work.
Yeah. So show you again that the screenshot of what it looked like when it started in 2007, and we've changed it to look like this now. So this is ThinkSpace 2.0, and throughout, in between those two designs, there's been multiple iterations, and I'll talk about some of our processes and how we got to that design. But for now, ThinkSpace is basically a platform. It supports currently 3 of these platforms: PDAPM, Kspace, and Serial Commons. And the hope is that we'll get more, and then it'll be almost like an application hub where, as you add more, then each one will benefit from being in this ThinkSpace wrapper. So one of the things, one of them that I can explain. So 2 of the original research projects or platforms that started this whole ThinkSpace platform is the PDAPM, which is set for Professional Development Algebra Progress Monitoring. So PDAPM is a platform that supports professional development among algebra teachers, and it also supports the monitoring of the progress of the students throughout the year. And then you can see a little video of what that platform looks like. So they're going through the graph. And that's what you can use to monitor the progress of each of the students. Another one which is widely used right now, and it's very cross-disciplinary because we have a lot of different groups using or having cases on this platform, is CaseSpace, which it contains all structured real-world scenarios, and they're designed in a case study type of way. So in one of the screenshots that we showed, it was a vet med case or veterinary medicine case, where the students are usually asked to diagnose an animal, and there's a process that you go through from gathering the history of the animal to finding what the actual diagnosis is. And that's something we've been using CaseSpace a lot to implement those assignments. So this is another little video of what the UI looks like for that. And that's just going through each of the phases in that assignment. So going back to actually the big picture of ThinkSpace. So what ThinkSpace provides these platforms is the standardization of the navigational structure and also the design. So then these little platforms can focus mainly on the content and not so much on the UI point of it that ThinkSpace can take care of that. So one of the important things in ThinkSpace 2.0 was getting a lot of user research or UX research in there to make a smooth and easy to use platform that people can enjoy using. So the good thing about also having ThinkSpace as the shared UI is that when we do user research on these individual platforms, like let's say CaseSpace or PDAPM, they start informing the design also of the other platforms as well, since they're sharing that design. And so the idea is if you add more platforms, then you'll get that benefit of all the prior user research. So this is kind of what we've been doing for the past year. We conducted 12 interviews with faculty, and from that we created 4 personas that we can use for the design. We can go, instead of having to do more interviews, we can always access these personas and ask what these people would do in ThinkSpace, and that informs the design. We've also had 3 stakeholder workshops to figure out and learn more about the process within these disciplines or the groups that we've created platforms for. And we've had so far 35 comprehensive usability tests with faculty and students, which have helped iterate the design of ThinkSpace as well. So some of the things we've been learning with all those interviews and usability tests is that users really appreciated the attention to the best teaching practices that was baked inside ThinkSpace 1.0. So we wanted to keep that in the design. And what we also saw was that there's these common problem-solving patterns within the cases that the disciplines were having the students do. So one of them, and we categorized those patterns into 3 groups. So one of them being data collection, which faculty or teachers would ask the students to collect data based on like a paragraph or some type of data, primary data that the student was asked to read or go through. And then data exploration was once that student created that list of data that they gathered, then they would use that to create or answer some questions. So using whatever they learned from that paragraph, what can you tell me about, or what can you create with that? And then the feedback phase was just once you created that new thing, let me give you some feedback so you can reflect and see how you could have done it differently. So with the navigation, people or users were having trouble understanding where they were within ThinkSpace, and when it came down to the cases where they not only wanted to know where they were, but also how much was left to finish that assignment. And the ThinkSpace 1 layout, they wanted more real estate for the primary content, and they wanted predictable locations for tools. That way, whenever they clicked on something, they knew exactly where it was going to be after that. They also wanted to have some confidence or something to assure them that, or something to notify that anything they were working on was successfully submitted or saved in the platform. So then we took those findings and used the design to kind of help inform a lot of those designs. So then, first category, I guess, would be the layout. So one of the things we did, and this is again, this is the snapshot of 2.0, is we separated the primary and secondary content. So the primary content would be the main thing that the user is focusing on, interacting with, and then the secondary content would be whatever the user's using to interact with the main content. So in this case, there's an observation list that, like you saw in that video, they're gathering little pieces of that paragraph and making a little list with it. And the secondary content then usually is where the tools come in that kind of power the ThinkSpace platform. And they each provide discrete functionality to each of the cases. For the pedagogy that we got from the findings, we took an assignment and we divided it into a sequence of phases, is what we call them. So instead of one big assignment, we chunk them up into little phases, and each phase can concentrate on a specific one of those learning patterns that I told you earlier about. So an example of one, in this case, the data collection. You see, there we go. There we go. So the data collection phase, again, the student has this paragraph where they're making a little list by highlighting. So then they're just collecting the data from that primary content. So that's one of the phase types. The second phase type that we made was a data exploration. So with those lists of observations, then they can create a path or an outline. So they're creating something completely new with something that they gathered from the first phase. And then we have the reflection and feedback. So whenever they finish answering questions, and they have instead of waiting to get feedback from the teacher, they can get direct feedback from, just by saying right under there, there's gray boxes. It's the feedback, and they can then have time to reflect to see if they need to change anything in their answers. So in terms of the way we handle the navigation is on the right side, we have a dedicated nav panel where the user at all times knows exactly where they are in ThinkSpace and also in the assignment, and it becomes like a little breadcrumb navigation that they can also click back, and they can just move around ThinkSpace using that. There's also a phase bar within the cases. So in the case of CaseSpace, you have a phase bar that tells you exactly where you are in the assignment and also what you completed and what you still need to complete. Now, since there are a variety of disciplines using ThinkSpace, we have very unique tools that are incorporated into each of the cases. So in this case, the veterinary medicine, they have something called the Diagnostic Pathfinder. So it's the same video we saw earlier, where they can create this outline based on the observations they had made. And another example of a specific discipline-specific tool would be the ADIME summaries. So in dietetics, they have a process that they also go through, and this tool documents each step of that process and gives a summary for the patient that the user can then also always reference while they're doing diagnosis and also monitoring the data for that patient. And another thing was sharing assignments between faculty. So if you create your own set of assignments and you want to disseminate that throughout your groups or your peers, you can do that with ThinkSpace as well. And now we'll do talk about the technology part of the ThinkSpace.
So I'm just going to talk a little bit now about how, what powers this under the hood, and kind of explain a little more in depth in terms of what is a tool, how does that work, how does it so modular to support these varying kind of use cases. So when we were kind of redesigning from ThinkSpace 1 to 2, we came up with kind of an initial set of goals that we had. Some of it was informed just from the development of ThinkSpace 1 that we wanted to continue to do, and some of the things were changes that we wanted to actually modify coming into the new version. So kind of the first goal we had was designers should be able to work in just kind of the baseline languages, HTML and CSS. We wanted it to be as easy as possible for a UX person or a front-end person to get involved in the project, make rapid changes to the interfaces, and we can adapt to that. Previously, they had to know some baseline JavaScript, and it could be a little kind of hairy around those parts. So that was kind of one of our main goals, was to overall increase the UX capabilities. The next one here, we get into a little more technical at this point. We wanted to have a Restful JSON API, was one of the things we knew. Whether that was served from a NoSQL or relational, that was something that we spent quite a bit of time evaluating. Like I had said, ThinkSpace 1 was a flat file XML-based NoSQL solution. And so we had kind of worked with that. We worked with CouchDB, MongoDB, and other things as well. Long story short, we ended up using a relational database, and a lot of that was informed because we wanted to be able to do ad hoc queries for researchers that needed data sets that weren't necessarily a report that we had already had kind of coded into the system. They wanted to do something kind of ad hoc. And obviously we could do that with map and reduce queries and things like that, but we wanted to make it as straightforward as possible. So with our Postgres database, we did choose to obviously do the Restful JSON API. One of the other kind of big goals we had is we wanted the client to be completely separate from the back end, the server side. We wanted a front end that would consume this JSON feed and that we could adapt and change over time based on kind of the needs of the system. And lastly, we wanted, we wanted to be able to control the scope of the payloads, which is kind of an interesting concept. But the reason that we wanted to do that is because I wanted to be able to deliver an entire assignment of worth of JSON at once, excluding obviously third-party assets or images, things like that. But I wanted to be able to deliver a full assignment or a full case at once, and also have the ability to load it kind of as an on-demand basis on an asynchronous kind of level. And the reason that ends up being kind of cool is because it allows us to pull in an entire assignment, and it really helps with the usability, because at that point they don't have to go back and load anything from the server, and it starts to stage kind of an offline mode concept. If you were to sync to local store, for example, once they reestablished internet connection, we could then sync back to the authoritative data source. So that's kind of why we want to be able to control the scope of the payloads, just to be able to cater to those kind of interesting ideas down the road. This one was pretty natural progression. Is we want to be able to deploy in the cloud or a local system. We wanted to make that as simple and straightforward as possible. Just the startup cost for having a university host something is quite high comparatively to just throwing it on the cloud somewhere. And so we cater to both of those. Again, as I said, we are not an LMS, but we are actually an LTI tool provider for Sakai and other LMSs, so we can integrate in those things kind of modularly there as well. This one of the things that we kind of ran into is with all of these different groups of research people, we didn't want to have them change their verbiage they were using in their research projects. So, for example, if we had a Department of Ed group that said, we have these forms, and then we also have vet med people that say, we have these forms, we didn't want to have to change that in the programming side. So we wanted to make sure that we could always namespace everything. And that, I guess it might seem fairly obvious, but we need to make sure the client side supported it as well, which was that was an interesting kind of dilemma we ran into. We want convenient packaging and deployment. We want to be able to version log things, ship it out, know what's out there, know what's in production. Currently, we wanted to support localization. We'll make the push towards full internationalization, once we get to that point. But that was just kind of one of the other things that we wanted to support kind of out of the box. So essentially, at the risk of starting a holy war, this is the stack that we came up with. Ruby on Rails is our server side. Our client side is ember.js with ember-data. Totem is kind of a support framework that blends the communication between the server and the client side. The reason that Totem exists is because we have the model view controller setups on Ember and on Rails. And so there's a lot of duplication that can go on in those environments. So we started to rip out the duplication, and that's kind of what Totem provided for us. We're using Postgres, as I mentioned before. We're using 9.3, which is, well, I guess this is 9.0 and above at this point. But they introduced a JSON column type as well. So it actually allows us to have kind of the schemaless NoSQL type approaches within our relational database. So for example, we can have kind of persistent caches rather than things in Redis and so on. And it ended up being, we like Postgres as well, due to the streaming replication and sharding and all of the kind of scalability approaches there that we can do to, once we cap out our database with our processing power, we need to be able to scale horizontally as well. So just to zoom in a bit on specifically the server side, Rails serves our RESTful API. Again, it's all JSON, and it communicates to Postgres, our authoritative data source. One of the interesting things and the real benefits of using Rails that we kind of came apart was the concept of a Rails engine, and that's basically a piece of modular code that you plug into a larger app. Essentially, you can provide a larger app with a set of functionalities, and that ended up being really, really useful for a number of reasons. One, it allows us to do things where everything in ThinkSpace is all engines, so it's all modularized. Every piece of functionality or every large piece of functionality is grouped into an engine. So, for example, if you wanted to handle your authorization differently on your ThinkSpace deployment, all you have to do then is just kind of swap out that engine for your own kind of customized engine. And that works out really, really well, so I'll kind of touch in a little bit. That's the core concept of the tools, and that's what allows us to kind of plug and play with them. Our Rails acts as our asset manager in our pre-compilation process, so it brings in all of our Ember JavaScript stuff into one or as many files as you want. It handles all the transpiling process from CoffeeScript to JavaScript or Sass to SC or CSS and kind of anything you want to throw at it. It kind of handles that out of the box, and that's just a pretty nice feature, so you don't have to burden the developers with implementing any other kind of workflows for that. Rails is, it's Ruby on Rails, and so this really isn't something Rails provides as much as the Ruby language itself. But in addition to all of our tools and everything being engines, they're also Ruby gems. So that allows us to disseminate them, push them up to a Ruby repo, allow other people to pull them down fairly easily. And that's been something that's worked out really nice for us as well. The server side is responsible for our background processing. It's kind of our application server. In kind of the OAE context, these are our Hillary containers. That's kind of how we handle that as well, very similar to what they do. Rails also turned out to be pretty nice due to the deployment options. I mean, you have multi-threaded, multi-processed, hybrid web servers. You have just multi-threaded. You have ones that handle copy on write and rolling restarts. And there's a healthy set that you can kind of choose from, just kind of cater towards what you need. Currently, we're deploying with Passenger Fusion, which works on Nginx and Apache, handles the reverse proxy scenario, and all of that kind of stuff. So performance-wise, that ended up being pretty solid as well. So the client side, I mean, this could be several boot camps in and of itself to talk about Ember. We started dabbling with it back when it was Sprout Core, kind of the precursor, and we've done Angular and Backbone and all of those things. But Ember was a fit for kind of the Rails ecosystem, just kind of the people that were involved with it. And I tend to like opinionatedness in frameworks, so we kind of went this route. And it was a gamble at first, for sure. It ended up working out really, really well for us, with the exception of ember-data still not ready for production, so it's still kind of hairy. We've had to do a lot of kind of extensions of that ourselves. But Ember.js has worked really well for our client side. It naturally consumes JSON. It naturally turns those into models. It allows us to handle those big payloads that comes in to make, to bring into the local memory as many models as we want, to allow to go through an assignment without having to request anything from the server again. And on the flip side of that, it allows us to only request what we need to display that page. So it's worked out pretty well for that. The templating, which is done through handlebars, has worked out fairly nice. It's simplistic, nothing too crazy there. It's just your standard kind of JavaScript template. Totem, again, I've already kind of covered on this. This is just the glue that helps us manage the. We have a form model on the Rails side and the Ember side. How do we keep those things in sync? How do we keep the namespaces in sync? And all of our JSON is actually keyed with the namespaces in it. So we have all of that taken care of. And Totem essentially dictates what does our JSON serialization look like. It just helps with kind of all that process. it provides, we have a lot of Totem level Ember stuff that just helps, extensions on namespaces, extensions on models. Totem is kind of the base model, the base controller that we extend off of for everything. And so it's just kind of the lowest level there to help bridge that gap. For testing, for server side, we used mini test, we used RSpec at one point, and we used unit test for Rails at one point, or Ruby, I guess. But we ended up on mini test just because it's simple. That's now what Rails 4 and above is bundled with out of the box. For the client side, we use for our integration and our functional tests and unit tests, we use QUnit, and it is, ThinkSpace was designed with Travis CI and those type of things in mind. So we have a Phantom.js process that will run all of our client-side tests on Travis CI, and then it will report back success, failure, and all that stuff. So kind of bringing this all together in terms of ThinkSpace, like what are the implications for it? There's, we've talked about this tool concept, which in case space, all of the observation list is a tool. The ability to display a paragraph of text is another tool. The ability to display expert comparison is yet another tool. And that ends up being really nice with the engine concept, because what that allows us to do is, if you have a ThinkSpace deployment and you want to add a new tool, all you have to do is just load the gem in there and mount it as part of your kind of main app. After you do that, there's one additional step that's just a single row in kind of a domain table in the database that allows us to click it in a drop-down menu, essentially, so it's registered in the system. But that's ended up being really nice for a couple of reasons. One, because we can easily add things or remove things as you see fit. And two, it allows for, for example, if Iowa State wanted to modify diagnostic path a little bit, and they didn't want to use ours out of the box, all they have to do is simply just replace that particular gem with their customized version. And so overall, that's given us a lot of flexibility, and it caters towards kind of we call it the application hub, which is a collection of these tools that you can add to your installation, or I guess remove, but that wouldn't make sense for that context. But it's a list of all of our tools that you can then add to your specific ThinkSpace installations. And we hope to grow that kind of over time. But so kind of as a roadmap, just to wrap things up here, just to kind of give you a picture of where we are in the development, because we started in 2007 on ThinkSpace 1. ThinkSpace 2 has been in development for about a year, somewhere around there. A lot of that was kind of on the foundational stuff. But this month, shortly after we get back from the conference, we'll be deploying to our first kind of small group just to test for bugs and things, make sure it works on a variety of systems and so on. And that's primarily for the PDAPM project and the veterinary medicine people with the diagnostic path. In August 14, we'll roll it out to a slightly larger audience at Iowa State, so it'll be kind of physics, veterinary science, as well as dietetics, and the algebra kind of project as well. Spring 15, we hope to have the ability to do the full kind of rollouts, and we'll do that's where we'll have the ability for any educator, any faculty, anywhere to create cases themselves from scratch and things like that. Our kind of community site is thinkspace.org. That shows a bunch of faculty members who have used it, how they use it. There's videos about what's the context of, how do they use it in their classroom, why was it beneficial from a research perspective, and all of those kind of questions. So, other than that, that is, if there's any questions, we'd be happy to answer. So.
Is this released as an open source basis?
Yes, yep. Yeah, so part of the roadmap is right now we're still, it's still in the private repo on GitHub right now, but we will be open sourcing it hopefully around that August deployment date. We want to make sure there's enough documentation around the key components and all of that kind of stuff before we kind of unleash it. We don't want to have to spend all the time supporting people until the documentation is in place. But Totem and ThinkSpace are both open source platforms once we get that pushed out.
So is there any standardized like SCORM or some other industry standard that you can use? But these are parts of something that we could embed into a compliance layer or something that you don't necessarily have to install anything, that you just use the existing SCORM layer.
The only source of standardization that we have that I was kind of mentioning was just that we are an LTI tool provider, so we can be hooked into Sakai and things like that. Other than that, I'm not sure if that answers your question directly, but. Thank you very much.